Okay, so I'm actually going to make a video just on the class opener and then a separate video just on the lesson, right? Let's jump into answering these questions with regards to the g of x function. So the vertex, we find the vertex by applying the vertex formula, which is x equals negative b over 2 times a. And of course, when you use it, please use parentheses instead of your variables. So you could plug in your actual values of b, which is negative 24, and a, which is negative 6. So you have a negative 24 up there and a negative 6 down here. So your x is really positive 24 over negative 12, which is negative 2. Now, the vertex formula reads x equals negative b over 2a. That means that it only provides you the x value of your vertex. So your vertex is a coordinate. Your x value is the negative 2 that we just found using the formula. Now, whenever you have the x and you want the y, all you have to do is plug in the x to find the y. Now, this is a g of x function that's just like a y, but we call this function notation. So we might as well use function notation, and I want to rewrite it as g of negative 2. Now, this is not really that important, but it kind of, what this says is that we're about to plug in the value of negative 2 in place of x into the g of x function. That whole sentence that I just said is all stated right here in this function notation, g of negative 2. So normally I don't write this notation, but I want to start writing it, right? So let me plug it in. We have negative 6x squared minus 24x minus 25. So we are plugging in a negative 2 into those parentheses. And doing the math, you start with exponents. Negative 2 squared is positive 4. So you will have negative 6 times positive 4, which is negative 24 as the first term. In the second term, we have negative 24 times negative 2. That's going to be a positive 48. And then bring down the minus 25 at the very end. Just bring that down. So you really have 24 plus 48, which is positive 24. Take away 25, which is negative 1. So all that equals a negative 1. If you use a calculator, you'll see that that equals negative 1. And that is the vertex y value, negative 1. The vertex y value. So we have found our vertex. Everybody cool with finding the vertex? Something that we should already know how to do, something that you're going to have to do for many, many lessons in Algebra 2. The axis of symmetry. If I were graphing the g of x function, I would first find this vertex the way I did it right here. I would plot this point. The most important point is the vertex. And the second thing to do after drawing your vertex is to draw your axis of symmetry, right? Which is, I usually do a green dotted line right through it. But the equation for that axis of symmetry will be x equals, anybody know? Negative 2, the x value of your vertex. That's right. So that is the axis of symmetry equation. This does produce a vertical line crossing the x-axis at negative 2. Now, after that, we need to answer, is it a maximum? Does this have a maximum or minimum value? What do you guys say? Is it a maximum or a minimum? Max, min, and how could you tell? The A. If the A value is positive, it's going to open up. If it's negative, it's going to open down, right? So this is negative, which means it opens down. And not only that, the 6 tells you that it's going to be narrower than usual. It's a vertical stretch by a factor of 6. But anyway, since it opens down, we know we're going to have a max value. So let's write down max. And where is that max value at? Is at the y value of what? Negative 1. Simply the y value of your vertex. So whatever your y value is on your vertex, that is going to be the maximum. Okay. After all, the vertex is the maximum or minimum of the parabola. So just for funsies here, let's do a quick sketch right here on this blank spot. So where's my vertex at? It's at negative 2, negative 1. So negative 2 on the x, negative 1 on the y. It's about right here somewhere, right? That's a vertex, negative 2, negative 1. We do know that there's an axis of symmetry crossing right through it. We do know that it opens down and it's slightly narrower because it's vertically stretched by 6. It's actually way narrower. So this thing is opening down and it's pretty narrow. Okay, so that's just the sketch. They're not asking us to graph. I'm just sketching it so you could understand, have a visual of what kind of parabola we have, this g of x function. All right, so they're asking us to find the x-intercepts. How do we do that algebraically? How do we find the x-intercepts algebraically? Anybody? Set?
Y equal to 0.
That's right. Set y equal to 0 and solve. That's how to do it. How do you find the x-intercept? You set y equal to 0 and solve. So what would that mean with regards to this equation? Well, the g of x, that's your y. So what we're going to do is rewrite this whole thing and set it equal to 0. So I could put equal 0 on this side, which will be on the left side where the g of x is at, or I could put the equal 0 on this side. It doesn't really matter. Either way, if it's equal to 0, I need to solve this thing. I would have to use the quadratic formula, right? Which would take a long time. But what do I know about the x-intercepts of this parabola based on the sketch that we have? It doesn't cross, right? So it does not have x-intercepts. So we could put number 4, does not cross x-axis. So number 4, find the x-intercepts. There are no x-intercepts. You could put none. You could put there are none. You could put it does not cross the x-axis. That doesn't mean that it doesn't have solutions, because if we actually solved it, we'd just get an imaginary values. Moving on to the y-intercept. How do I find the y-intercept?
Set x equal to 0.
That's right. Set x equal to 0 and solve. Now, finding the y-intercept is the easiest thing in the world when you have a quadratic trinomial that's in standard form. Because if we look at this quadratic trinomial in standard form and we set the x's equal to 0, this is going to become 0, that's 0, this whole thing's 0, your c value will be your answer to the y-intercept. So you could just look at any standard form quadratic trinomial equation and you will see the y-intercept. What's the y-intercept in this case? Negative 25, thank you. Now it's time for domain and range. Well, the domain on any parabola is going to be x equals all real numbers, because the parabola will go to the left and to the right forever. And the range is going to be your y values, and it's either above a certain value or below a certain value. So of course you need to use your vertex for that. The vertex is -2, -1. So the whole parabola is at -1 or below -1, right? So what are we going to say? Y is what? Less than or equal to -1. Any questions? Now for the final step, we need to describe the transformations from the original parent graph of f of x equals x squared to the new g of x function above. So let me attempt to show each transformation. This is going to be ugly, but try to bear with me here. The original parent graph, f of x equals x squared, that one has a vertex at 0, 0. The a value is 1, which means it has a pattern 1, 1, 2, 4, 3, 9, right? So it's your regular parabola, not too wide, not too narrow. It's a perfect parent graph parabola, right? So what is the first type of transformation that happens from this blue graph to get to this new g of x function? The first transformation is going to be based on your a. So what's the first transformation you say? It flips, right? Okay, now that's like using slang, right? Let's use math vocab. It gets reflected over the x-axis. So let's write that down. The first transformation, it gets reflected over the x-axis. Yeah, that means that it flips, that it opens down, right? I mean, you would probably say that it opens down because it's negative, but let me actually demonstrate that. Opening down, we'd end up with the same parabola, but just opening down. So that's the reflection part. Now, what else happens? What's the next transformation? That is correct. The next transformation is that it gets vertically stretched by a factor of 6. So let's write that down. So the parabola, because it's the a value -6, not only does it open down, but it's going to get narrower. It's going to get stretched. So let me actually stretch that out. I want to use yellow. It's going to get really narrow like that. Okay. Let me write down that actual description, that it gets vertically stretched by a factor of 6. Again, the closer the a value is to 0, the wider it gets. The further away it is from 0, the narrower it gets. That's why it's a pretty narrow yellow parabola right here. And now for your final step, or your final transformation that you need to describe, those are the shifts, right? Shifts. So where does it shift? From the original 0, 0 vertex, it shifts where and where to your new vertex?
2 units left and 1 unit down.
2 to the left, 1 down. 2 to the left and 1 down. Okay, so we're going to take this vertex that's at 0, 0 and move it 2 to the left and 1 down and put it right here. So it's going to end up right there. So that yellow narrow parabola is still here, but now it's in red. And that's my final parabola right there. So we've described all the different transformations. Now, yeah, it's one thing to just explain what's happening, like, oh, if the A value is negative, it opens down. Yeah, but the correct math vocabulary gets reflected over the x-axis. Oh, it gets skinnier, it gets narrower. Yeah, but the correct math vocab is that it gets vertically stretched by 6, right? And then finally, moving it 2 to the left and 1 down, you just say shifts 2 to the left and 1 down. There's some math books that say translates 2 units to the left and 1 down. Anyways, that's transformations. And that is the entire class opener. And you should know all this stuff, and it will appear on our next quiz this Friday. Okay, let's move on to the actual lesson for today on the next video.